Hello everyone, I am Nishant from Sri Venkateswara College of Engineering, studying in 5th SEM. Subject I took is Computer Network. The topic I picked from that subject is an improved transport layer protocol for wireless sensor networks. First abstract. Wireless sensor network are a kind of communication network having a independent sensor node that form multiple hop and HOC network to transfer the data. In the past few years, various transport protocol in a wireless sensor network have been depended and proposed in a literature. In this paper, we have analyzed a pump slowly fetch quickly protocol and presented an improved transport layer protocol for a wireless sensor network. Improved protocol has been analyzed based on the various factors such as average latency and average error tolerance, and it is found that the proposed protocol is better than PSFQ in terms of these factors. Introduction. Wireless sensor network is a self-organized distributed system consisting of one or more base station, which are usually called sink, and perhaps tens or thousands of sensor node sprinkled in a physical area. In, inten, Integration of information sensed through a sensor's computation on that and a wireless communication makes a sensor node available to gather a physical data, process that data to obtain crude information and report to sync. The sync can query the sensor node for more information. WSNs have several characteristic features. The major focus in this paper is on the design of a transport layer protocol for WSNS. Transport layer protocol are used to migrate a conjunction and reduce the packet loss to provide a wireless or a fairness in bandwidth allocation and to guarantee end-to-end reliability. However, UDP and TCP transport protocol, which are currently used for the internet, cannot be directly implemented for WSN. For example, a UDP does not provide a delivery reliability that is often need for many sensor applications, nor does it offer a flow and conjunction control that can lead to packet loss and unnecessary energy consumption. Related works for WSNS, various transport layer protocol have been designed to address various issues such as conjunction control, reliability, or both. A brief summary of the related protocol is provided in this session. STCP is a generic end-to-end upstream transport protocol. It provides both the conjunction control and reliability by allocating most of the responsibility at the sink. It provides a controlled variable reliability utilizing the diversity in the application. Garuda is a reliable downstream data delivery transport protocol for WSNS. It addresses the problem of reliable data transfer from the sink to the sensor. Its design is a loss recovery core infrastructure and a two-stage neck-based recovery process. RTMC is inspired for a pipe flow method and provide a hope by hope transmission to make sure all of the segment can be received by the sync with 100% reliability. Analyzing of a PSFQ protocol. PSFQ is an hope by hope downstream transport protocol which is reliable, scalable, and robust. It uses a neck-based loss detection and a notification and local transmission for loss recovery and is basically designed for retasking or reprogramming application which requires 100% packet reliability in a downstream direction. It consists of a three operations: pump, fetch, report operation. The pump operation controls the rate at which data packets are passed into the network. The fetch operation requests a transmission of the lost packet from the neighboring node. Lastly, the report operation provides a feedback status to the user. This ways it provides 100% packet reliability. Message transmission. The pump operation controls the injection of packets into the network. This operation is important in controlling the timely distribution of the code segment to all the sensors node and providing a basic flow control so that the reprogramming operation does not obstruct the regular operation of the sensors network. For doing so, proper scheduling is required for data forwarding. PSFQ adopts a simple scheduling scheme which use two timers, Tmax and Tminimum. The important task of PSFQ is to recover the lost packet very quickly among immediate neighboring node within a controllable time frame. For that, there is a need to provide a time buffer. T minimum gives an opportunity to the node to recover any missing segment before the next segment comes from its upstream neighbor. Since a node must wait at least before forwarding packets as a part of pump operation. Local loss recovery. Sensors node starts a PSFQ fetch operation to do a local loss recovery. It is started when a sequence number of gap is in a file fragments is detected. Channel impairment such as fading condition are always correlated in time. As a result, a loss of number of consecutive data packets occurs instead of single packet loss. Therefore, PSFQs use the concept of loss aggregation. Whenever loss is detected, PSFQ combines loss such that the fetch operation deals with the window of the lost packet instead of a single packet loss. Sensors node usually has more than one neighbor in a dense network. PSFQ allows a different segment of a loss windows to do recovered from different neighbors. Shortage Shortaging of a firstly PSFQ does in a sequence forwarding of a data packets. For example, if any intermediate node running a PSFQ as its transport layer protocol does not have data packets 2 and as all data packets from a 3 up to last data packets, then this node will not forward any of the data packet to the next sensor node. In the same manner, Other node also remain ideal until they get in a sequence data packet. So this increase the time at which last data packet will reach to the target node. Secondly, there are some drawbacks into the pump and repair operation of PSFQ. Whenever in sequence data packets arrives, it wait for random time between T minimum and T max for forwarding the data packets. Nodes does not does this waiting by settling a schedule. Finally, in a PSFQ, same things as above happen while repairing the data packets. Repairing of a particular data packets will be failed if radio component is busy. As PSFQ does not reschedule the data packets to forward it ahead. Improved transport protocol out of order forwarding. Conclusion: we have initially represented various protocol available for a transport layer in a wireless sensors network. After that, we have presented overview of a PSFQ protocol. We provide some alteration to improve the PSFQ efficiency. We have also shown a performance analysis of the original PSFQ and improved PSFQ. It has been that improved protocol uh, work better than original PSFQ in terms of error tolerance and average latency. We have evaluated both PSFQ and improved PSFQ using simulation. We found that improved PSFQ has a good error tolerance and delivery latency. Thank you.